The problem is Tower of Hanoi. First of all, we'll learn what the problem is. See here, there are three towers given. These are the towers, three towers given. And in one of the tower, there are some number of discs kept. 1, 2, 3, 4, 5. So these discs are kept on this tower A. Now the problem is, we have to transfer all these discs from tower A to tower C. So we can just take out all these and keep them there. No, you have to take out one disk at a time. Move one disk at a time. Okay, we will transfer all these disks one by one in B. So first will come, the topmost will come here, then above that, then above that, then above that. Then from here we will transfer there. No, you cannot transfer like this. You have to transfer such that no larger disk should be kept over a smaller disk. So you cannot have a small disk kept here and a larger disk kept over it. This is not allowed. So two conditions are there. You have to move one disk at a time. Second thing, the larger disk should not be kept over a smaller disk. So by following these two conditions, you have to move all this n disk from tower A to tower C. For moving all these disks from tower A to tower C, we may require one more extra tower, so that tower B is given as a auxiliary tower. So we have to move disk from tower A to tower C, that is from and to, and this is for utilization, for helping. So this is using this tower, we are using the tower, that is auxiliary tower. So from is the source and to is the destination, and other one is using. Let us call it as using. So or else you can call the tower names as A, B, C. Now the problem is not so easy. It is believed to be unsolvable problem. There is some story behind this problem. It is believed that somewhere in the world there is a temple, and near the temple these three towers are there, and there is a tower with 16 golden discs, and few priests are trying to move this disc from tower A to tower C, and they are doing it from centuries, and if they are successful, then world will end. So that will be a doomsday. So there is a story behind this one. So it is believed that these towers and temple is in China or in India. So this was believed as unsolvable problem. But this problem can be solved using recursion. Let us see how recursion helps in solving this problem. So we want what should be the moves such that the disk can be transferred from A to C with the help of B. So we'll take some number of disks and we will try to devise a recursive function. Now we are ready to devise a recursive algorithm for this one. I have taken three problems here. One problem with a single disk and second problem with a two disk and three disks. Let us solve these problems one by one. So the first problem, there is a single disk. So simply move this disk from A to C. So the problem is Tower of Hanoi problem, where only one disk is given and we have three towers A, B, C, and there is only one disk. Then what we are supposed to do? Move disk from A to C, that is source to destination, from to, and with the help of tower B. Though we are not using this B here because there is only one disk, we don't need B, but I am writing it. That will help me write down other procedures. Now when there are two disks, Tower of Hanoi, two disks are given and three towers are there, A, B, C, then what I am supposed to do? See the topmost disk, I cannot move it to C, move it to B. So this topmost disk can be moved to B. So this is a small disk, come here. That is not the destination. That is the middle tower, intermediate auxiliary tower. So that is not the destination. So moving there is temporary or moving there is recursively. So that first step is Tower of Hanoi, one disk from, see this was the source and this was the destination, this was the middle auxiliary tower. Now we have moved it from this source to this destination We have moved from A to B. So for this single disk, topmost disk, C became an intermediate tower, or it is auxiliary tower. Actually, it's a destination, but we are not moving there. So we are moving here. So this becomes source and this becomes destination, and that becomes a using tower or auxiliary tower. So C, I will write it in between. Then first step is over. Now second step, move this larger disk from here to C. One disk from A to C, direct A. So that step is same as this one. So move disk from A to C using B. So though we have not used, but we are saying that we are using B. So the other tower, auxiliary tower, we are mentioning it. So this is move from A to C. That is same as this step, first step. We have already seen how to move one disk. That same step is useful here. Now what is remaining? From tower B, we have to move a disk to tower C, and this becomes an auxiliary tower. So that step is recursive step. So let us call it as recursive step. Tower of Hanoi, one disk, and the source is B, destination is C, and auxiliary tower is A. So these are the three steps I got. So here I am saying move disk, right? Then what about this? This should be performed as per the first step, and this also should be performed as per that first step. So this is recursive. So this definition I have written recursively. Now if there are three disks, how to move them? Let us see. Tower of Hanoi, three disk, source tower, intermediate tower, destination tower. Now we have three disks. How to move three disks? If I number them 1, 2, 3 from top, then how to move them? Now for those steps, we will use a trick here and define recursively. Observe this. I'll say that move these two disks to tower B. Move these two disks to tower B. Two disks we cannot move at a time. No, we are not moving two disks at a time. Those two disks are moved by following this method. We already know how to move two disks. We saw how to move two disks from A to C. The final disk was kept here, right? So A to C, how to move we saw. Now instead of A to C, you have to move them from A to B, right? So that is not in one step. That is in three steps. So moving two disks from tower A to tower B takes three steps, which will utilize a tower C or B something. Somehow they will be moved. So how to move? If you want to see that, follow these steps. So to make this problem simple, we are saying that move two disks. So moving two disks is not just one step, it is recursive. So how to move two disks? Already step is given. Then again, how to move one disk? Already step is given here. So let us write down that first step. First step is tower of Hanoi, 3 minus 1, 2 disk. From where to where? A to B. A to B. And C is the intermediate tower. Okay, when two disks are moved there, now third largest disk is remaining. Move this disk to tower C. Third disk. So second step is move disk from A to C using B. So move that one. Though we are not using or we are using it or not, there's a different thing. Using means the intermediate tower. Now, what is remaining? You have to move two disks from B to C. Two disks you cannot move at a time. But how to move those two disks in multiple steps already shown here. So follow those steps. Now source is not A, source is B and destination is C. So A is an auxiliary tower. So this involves multiple steps, but we write it as a single step here. So the third step is tower of Hanoi, two disks from B to C using A. That's all. So these three steps, so we can see that when we have three disks, we can perform it like this. So now from this three disk formula, Now from this 3-disk procedure, we can generate the idea for n number of disks. So suppose this is n, then what it should be? N minus 1. Then what this should be? N minus 1. That's it. Because this is recursive, recursion will call itself again. So there are more steps below that call. So don't imagine it's a single step, but we are able to define it recursively. So for defining it recursively, I made a simple problem, the next little bigger problem, then little bigger problem. Now this is suitable for all n number of disks, not just 3 disks. It is suitable for any number of disks. So I have converted that into n. Now I will write down this as a recursive function, and I will take an example and trace this function and show you really these steps will solve the problem or not. Now here is a recursive function for solving problem Tower of Hanoi. Based on our discussion, the final function that I got, the final algorithm that I have written it as a function. So let us read it out. So it is taking 4 parameters: number of disk, tower number. A, B, C are first 3 tower numbers. A, B, C are 3 tower numbers. Then if number of disks are more than 0, then perform these 3 steps. So first step is recursive call with 1 reduced disk, that is n minus 1, and towers are changing. See, this was from tower and this is to tower, so this is using. Now in the first step already we saw that we will move this disk from A to B. So from tower is A and B tower is 2 and C is using tower. Then move a disk from A to C. So I wrote it like this because of lack of space. Then next one, you have to move n minus 1 disks which were kept in B from B to C. So source is from is B and destination is C, and A is auxiliary tower. So I will trace this one and see how this function will solve Tower of Hanoi problem. And this is an example problem. Here the number of disks are 3 and tower A, tower B, tower C. I'm not calling them as A, B, C. Actually, those are variable names. So values in them are tower 1, tower 2, tower 3. So 1 and 2 and 3. So slight change here. Those are actually variable names. But in them, the values, the name of the tower, I have to take it integer. Otherwise, I should take them as characters. So instead of characters, let us take integer. So tower numbers are there. 1, 2, 3 tower numbers are there. Now, if this function is called by passing these parameters 3, 1, 2, 3. So this is n and this is A and this is B, this is C. So these 4 values are passed. So now let us trace this one. So here the first call, I will write it as a first call. Number of disks are 3 and the tower numbers are 1, 2 and 3. So these 4 values are passed. N is greater than 0, yes, n is a 3. Then what to do? Call itself by n minus 1 and the values are changed. So let us write down this call. So this is n minus 1. This is 2. First is A is 1. Next is C, so C is 3. And last one is B, that tower number is 2. Yes, these are changed. Now this call has to be expanded, but before expanding I will write down other 2 steps also. It will be easy for writing. Print move from A to C. So A to C. So this step is from 1 to 3. So move a disk from A to C. So A is 1 and C is 3. Then third step. This is step n minus 1. So 3 minus 1, that is 2. And B first, so that is 2. Then A next, that is A is 1. And last one is C, that C is 3. So as we know the working of recursion, this call is making 2 more calls. So first call has to be finished first, then it will print this one, then it will call this one. So we know that, but we have written all of them together at once, so that's easy to write. Now let us continue. This call will be performed. So as per this call, again 3 steps, because this is 2 and 2 is greater than 0. So for that, what are the steps? So first step, A, C, B. So this is 1, A, C, B. Right. The next, print AC. Print AC. So 1 to 2. 1 to 2. See, it is not a. So last tower is not 3, it is 2. So 1 to B, it means A to B. Then this is step 1, and this is BAC. 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 3, 1, 2. This is the call. Then I'll expand this one also, though this is done afterwards. Let us expand this. So for this, first call, ACB. So this 2 will become 1, A, C, B. The next step is move A to C. So what is A? 2. C is what? 1. So 2 to 1. Then third step, N minus 1, BAC. N minus 1, BAC. So 1, 2, 3, BAC. Middle one is B. See, as per the variable names, you see the variable name ABC. So this is A variable name and its value is 2 now. This variable name B and its value is 1 now. So we take the values of the variables. So this BAC are the variable names. So this is B variable and this is A variable. This is C variable. This is written. One more level of steps I have to write, but this time the call will be for 0. 0. Now when it is 0, it has no meaning, because when it is greater than 0, it is performing. So next step will not be performed. So this call will not execute at all. So checking the towers and writing them is useless. So I will avoid writing the steps. So if I have to write, the first step is ACB, that is ACB, that is 1, 3, 2. Though it's of no use, it's going to terminate. So I will avoid this one. Then what is the next step? Printf A to C. A is 1, C is 3. 1, 3. The next step is again 0 with some values. Then for this step is 0 with some parameters, and this is move from 3 to 2. So 3 to 2. This is 1 to 3. A is 3 and C is 2. So 3 to 2. And this step is again useless. Now for this, left hand side is useless because the function will not execute. Then middle step, move A to C. So 3 to 1. Move A to C, that is 2 to 1. So 2 to 1. And this step again of no use. Then here, left hand side of no use, middle one, A to C, 1 to 3, 1 to 3, then right side 0. So actually these steps will not be performed, these will not be performed. So I'll just mark them to show that these are not required. Now let us see how these calls are made and take those results. See, first this is the call, first call, then second call, then third call, then fourth call, which will not execute, so I marked it as which will not execute, so I have striken off that. Now next step is 1 to 3. So the first step is 1, 3. This is the first step. Then this is the fifth call. Then go back. This step is performed. So the step is 1, 2. So 1, 2 is the next step. Then this call, sixth call. Then seventh call. Then this step 3 to 2. So this is 3 to 2. Then eighth call. Then go back. And this is step 1 to 3. 1 to 3. Then next, this is the ninth call. And this is the 10th call. 11th call. then 2 to 1. So this is 2 to 1. Then this is the 12th call. Then this 2 to 1 is printed. Oh, sorry, this was 2 to 3. I wrote it as 2 to 1. A to C, 2 to 3. So this is 2 to 3. Then 13th call, 14th call, and then this 1 to 3 step is 1 to 3. Then this is the 15th call. So total 15 calls it is making for 3 disks. But let me show you the values once again. See, first call is this one, then this call, then this call, then this call, then this value is printed. So first this value is printed, then this call, then over, then this is the next value printed, then goes back, and this is the next value printed, and this one is printed next, and then it comes on this side. So 2 to 1, and then 2 to 3, then finally 1 to 3. So the values are printed like this. So if you know the tree traversal, this is more like in order traversal. So the printing is done in order traversal. So these are the steps I got. If I follow these steps upon this problem, then the disk will be transferred from tower A to tower C with the help of tower B. So I will take these steps and show you how it works. But before showing you that, let us analyze how much time this is taking. See, there are 3 disks. Number of disks are 3. So how many calls it is making? This is making 15 calls. When n is equals to 2, how many calls it will be making? So let us look at the subset of this one. So 1, 2, 3, 4, 5, 6, 7. So it is making 7 calls. So actually for 3 itself, if you see 1, then 2, then 1, 2, 3, 4 calls, then 8 calls. So this is nothing but 1 plus 2 plus 2 square plus 2 cube. So these many calls it is making. So this is nothing but 2 power 4 minus 1. That is 16 minus 1, 15. So for n disk, how many calls it will make? I'll write them here. 1 plus 2 square plus goes on to 2 power n. So this will be 2 power n plus 1 minus 1. So this is order of 2 power n. So this is exponential time taking problem. The function is calling itself 2 times by decreased value of n minus 1. So 2 times it is calling 2 power n. So this is time consuming function. It's exponential time taking function. It takes 2 power n time. Now I will take these steps and show you how the disk can be moved. Now here are the steps that we got from the function, and here is a problem with the 3 disks and the tower numbers. You can see I have labeled them as 1, 2, 3. You can call them as ABC also. The value of A is 1, B is 2, and C is 3. So I have taken numbers, and these steps are giving numbers. Now let us follow these steps, perform these steps over this disk and get the result. First step, what does it say? Move a disk from tower 1 to tower 3. So from tower 1 to tower 3, we have to move a disk, and we know very well that we have to move only one disk. Right? No need to ask how many disks. We have to move one disk only. So one disk, move it from this tower to this tower. Tower 1 to 3, 1 to 3. Second step, move a disk from tower 1 to 2. So from tower 1 to 2, which is the disk? Now the second smaller disk we have. So move that one to tower B. Over. That is from 1 to 2. The next step is 3 to 2. So third tower to second tower. Okay, move this disk from third tower to second tower. This is moved. The next step is move a disk from tower 1 to 3. From tower 1 to 3. So this largest disk, you send it on tower 3. Okay. Largest disk is sent on tower 3. Now, next is move a disk from 2 to 1. So from second tower to 1. So this smaller disk, you bring it here. Then move a disk from second tower to third tower. Second tower to third tower. So this second largest disk, that is middle disk, you send it on third tower. Then Move a disk from 1 to 3. So from first tower to third tower. So move a disk from first tower to third tower. That's all. I have followed these steps and all the disks are moved from here to there. See, the definition was recursive, saying that move two disks from tower A to tower B. Really, we were not moving two disks in one step. We were moving them recursively. So we have utilized one or the other towers and we have shifted the disk here and there. And finally, we got all three disks in tower C. So that was the objective. If you're not following the steps, if you're randomly trying to do, we may be wasting our time by performing unnecessary steps or repeating steps. That is the problem. Now, recursion gives us perfect minimum number of steps, exact number of steps. If you follow that, you can move the disk from one tower to another tower. Now, that's all about Tower of Hanoi problem. Now, for you to remember it, you have to work on this one. So practice this one once and then you can easily remember this one. And this idea will help you solve other problems. This Tower of Hanoi idea will help you think recursively.